unknown I center, that is 1, 3. So that need to be joined by dotted line. So I am joining 1, 3 by dotted line. So once I join these two, I can get two triangles. One is 1, 2, 3 and other one is 1, 3, 4. Right? So look at 1, 2, 3. So there are I centers 1, 2, 2, 3 and 1, 3. And if I look at 1, 3, 4, then there are I centers 1, 3, 3, 4 and 1, 4. So you can see 1, 3 is common. So as per Kennedy's theorem, we are taking three links together 1, 2, 3. So if I take three links together 1, 2, 3, then their I centers would be on the same line. Similarly, if I take another set of three links which are 1, 3 and 4, so their I centers 1, 3, 3, 4 and 1, 4 would be on same straight line. So based on this fundamental thing, we can try to find out these I centers. So what I can do, I can extend 1, 2, 2, 3 so that I can locate 1, 3. I can extend this both the sides because I am not knowing in which direction it is lying. Similarly, I can extend 1, 2, 1, 3, 3, 4 and 1, 4. So 1, 3 is unknown, 3, 4 and 1, 4 are there. So these are the 3, 4, 1, 4. I can extend this 3, 4, 1, 4. So once I extend this, so I can locate this 1, 3. So 1, 3 is coming somewhere here. So this point is O1, 3. So let's say 1, 3 is done. So I am putting tick mark over here. Then I can find out this I center 4, 6. So let's say I am joining it 4, 6 by dot line. So look at this 4, 6. So after joining 4, 6, I can get two triangles, and these two triangles are triangle 4, 5, 6 and triangle 1, 4, 6. 1, 4, 6. So here you can see in 4, 5, 6 you have 4, 5, 5, 6 and 4, 6. And here you have 1, 6, 1, 4 and 4, 6. So 4, 6 is common. Now look at 4, 5, 5, 6. So 4, 5, 5, 6 and 1, 6, 1, 4. So 1, 4 is this and 1, 6 is at infinity. So I can draw the path for 1, 6 here, right? So 1, 6. This can also be drawn here 1, 6 because it is lying at infinity. So once I extend this and I can see 5, 6, 4, 5. So 5, 6, 4, 5 and 4, 6 would be lying on the line. There is no need to extend because 1, 6, 1, 4 line is intersecting over here. So intersection of this indicating this is point 4, 6. So now I have located point 4, 6. So there are three I centers which is done. Two I centers we have determined. Now we can find out any other I center which we can try to estimate. So let's say I am joining 3 and 6. So 3 and 6. So once I join 3 and 6, so now I can get two triangles. These two triangles are triangle 1, 3, 6 and triangle 1, 3, 6 and 3, 4, 6. Triangle 3, 4, 6. So in 1, 3, 6 you can find 1, 3, 1, 6 and 3, 6. And in this you can see 3, 4, 4, 6 and 3, 6. So now 3, 6 is common. So if you look at here 1, 3, 1, 6. So 1, 6 is at infinity. So 1, 3 is this one. So we can draw at path of 1, 6. 1, 6 is at infinity, right? 1, 3, 1, 6. So 3, 6 would lie on this path. So now look at 3, 4 and 4, 6. So 3, 4 is this one and 4, 6 is this one. So I need to join these two. So I can join it 3, 4 and 4, 6. So I am joining these two eye centers. I am joining these two eye centers. So now after joining and extending, I can get it point 036. So this is instantaneous center rotation of 036, right? So now after this, what I can do, I can find out the eye center which is important for me. I cannot keep estimating all the eye center, that is not required. So what is required? Since in the problem it is being stated to find out velocity of point E. So velocity of point E, or this point's velocity. So this point is associated, or rather link 6. So I need to find out a common eye center which can represent link 6 and 2. In other words, I am more interested in O26 rather than anything else. So how do we estimate O26? Let us begin that part. So for getting O26, I need to join 2 and 6 because that is unknown to me. And now I can estimate O26 as well. So O26, this eye center I am interested in now. So this is creating two triangles here. One is 1, 2, 6 and other triangle is 2, 3, 6. Right? So look at 1, 2, 6. So 1, 2, 1, 6 and 2, 6. And if you look at 2, 3, 6, then 2, 3, 3, 6 and 2, 6. Therefore 2, 6 is common. So 2, 6 is common here. Then 1, 2, 1, 6. You have 1, 2 here and 1, 6 would lie at infinity. So I can trace the path for infinity. O16. O16 is at infinity. So this is the path. So 1, 2, 1, 6. 1, 2, 1, 6. 2, 6 will lie on this line, on this straight line. Look at 2, 3, 3, 6. 3, 6 is this one and 2, 3 is this one. So I can join these two eye centers. So I can join these two eye centers. So now I am joining it by broken line. So once I join 2, 3, 3, 6, 2, 3, 3, 6, I will get 2, 6. Oh, so I have located this. So this is O26 and this is important for me to find out velocity of point E, right? So O26 is not now known to me, and by calculating the velocity of O26, velocity of O26 would be the velocity of point E, right? So this is what pertaining to this one. Now, if we are interested in to find out velocity of rubbing of B, A, C and D, so we need to also get the velocity of link 5. So we need to find out omega 5, and to get omega 5 we need to have instantaneous center of rotation of link 5 with respect to 1. In other words, we are interested in 1, 5, O15. So now I am joining these 2 points O15. So this is 1, 5. I can use another color marker to differentiate this here. 1, 5 we can join 1 and 5. So once I join 1 and 5, then we can find there are 2 triangles which are coming here. One is 1, 4, 1, 4, 4, 5 and 1, 5, and another one is 1, 6 and 5, 6 and 1, 5. So 1, 5 is common. Now I can find out this eye center. 1, 4, 1, 4 is here. 4, 5, 4, 5 is here. So I need to extend this point. So I can get 1, 5. 1, 6, 5, 6. 5, 6 is here. Right? 5, 6 is here. So now we can extend. I can extend this point. 5, 6, 1, 6. So 5, 6, 1, 6. I can extend this. So after extending it, now you can find at somewhere these 2 points are meeting, and this point is nothing but O15. So in other words, this is the instantaneous center of rotation of link 5 with respect to ground. So now we have done with all the I centers which are required to estimate the unknown parameters like velocity of E and other things. So let's begin with finding the calculating the different unknown velocities. So first of all, we need to calculate velocity of E. So to calculate velocity of E, the first thing we need to do is to estimate the velocity of O26, assuming it is lying on link 2. So if O26, velocity of point O26, if it is lying on 2, so that is omega 2 into O12 O26, O12 O26. So what you need to do, as you have set the scale, this scale is a 1.7 centimeter. Now you measure this length. So once you measure this length, this is actually 170. If you measure this length, so this length is coming out around 32 mm. So we can put the value omega we have calculated 16.74, and if we multiply this distance 32 mm, this distance O12 O26, so we can get the velocity, and this is coming out 0.535. So this velocity is representing nothing but it is a velocity of point E, since O26 is a common point on link 2 and 6. So velocity of O26 will be same for link 2 as well as link 6. So if this point we can assume on link 6, so this will give the velocity of slider. Right? So this will give velocity of slider. So this is very important conclusion. You need to understand this. Therefore, we are so much interested in to find out O26. O26, again I am repeating, your 6th number link seems to rotating with respect to 2 about this point, right? So you can assume the 6th number of link is so much big, so that this link 2 and 6, they are meeting at this point. At this point they are meeting. Therefore, you can estimate this velocity. Now the next thing is to find out velocity of rubbing at different points. Let's say we begin estimating the velocity of rubbing. So we can start estimating the velocity of rubbing. So first of all, we can find out velocity of rubbing at pin A. So to find out velocity of rubbing at pin A, we need to have angular velocity of link 3. Since this link is rotating in the clockwise direction, that information we have, and omega also we have, but we don't have omega for link 3. So to do that, again we can write what is the velocity of O23 if we assume at 2. So it is omega 2 multiplied by 1223, and now similarly if I assume O23 at link 3, then it becomes omega 3, because I am assuming O23 is lying on 3. At the same time, if you look at link 3 is rotating with respect to 1 about this point. So omega 3 multiplied by the distance between this point and the center of rotation. So this point is nothing but O23, and the center of rotation for link 3 is O13. So now we can equate these two, omega 2, 1, 2, 2, 3 equals to omega 3, O23, O13. So once you equate these two, and then you can put the measurements is coming around 760 mm, this measurement, O12, O23, O13. So this is coming out 760 mm, and this is 16.74 multiplied by 0.17, and this is coming out 760 mm. So this is giving you omega 3. So now you can calculate these values, and the answer is coming out around 3.74 radian per second. The next question arises, what would be the direction of rotation? So if you see this point at A or O23, the velocity vector is drawn like this. So clockwise for link OA. But if you are looking from here for link 3, So if it is rotating like this, then this link go like this. So by observation you can say it is clockwise. But now we can make one rule saying that if these 2 points 1, 2, O12, this point O12 and 1, 3 are lying on the same side of O23, then the sense of rotation will be same. Again I am repeating, since in this case O12 and O13 are lying in the same side of O23, in that case sense of rotation will be same. So if it is clockwise, then link 3 also in the clockwise direction. Sense of rotation will be same. Right. So this is, we have got in nutshell omega 3 and omega 2 we know. So sliding velocity, rubbing velocity can be estimated. So rubbing velocity at pin A would be omega 3 minus omega 2, since both are moving in the same direction, into RA. This is nothing but the rubbing velocity at pin A. So this is rubbing velocity. To the next point. Next point is, we can also estimate the rubbing velocity at B, the second thing. So to estimate rubbing velocity at B, what we require, at B you require omega 3 as well as omega 4. So the next question arises, how do we estimate omega 4? So to estimate omega 4, again you have to consider this point. This point is nothing but O34. This point is O34. So we need to find out velocity of O34. So if you consider point O34 on link 3, and as you know link 3 is rotating in the clockwise direction, so this point as far this is concerned would be in this direction, right? So we can find out velocity of O34 if you are considering it on link 3. So it is omega 3 multiplied by O34 O13, O34 into O13, because link 3 seems to rotating about O13. Similarly, if I find out velocity of O34 considering it on 4, so it is omega 4 multiplied by this point. O34 is moving with respect to link 4 about this point C or O14. So the distance becomes O34 O14. So now we can equate these two. So omega 3 O34 O13 equals to omega 4 O34 O14. O34 O14. So now equate these, and once you measure, you know the distances. So I can just give the distance points. Now you can measure O3414, 3414. So 3414 is coming out 0.450. 0.450. So omega 3 multiplied by 3414. 3414 is 0.450, and this distance 3414 is known to us, that is BC, 0. Or you can say 510. So that is nothing but omega 4. So omega 3 we have estimated, omega 3 is 3.74. Now you substitute that value, so you will get 3.33 radian per second. That is omega 4. So now once you get omega 4, now there is a time to estimate their direction. So you look at this O34 and O14, O13. So O34 is lying at the middle, or you can say point O13 and O14 are lying on the either side of the O34. Therefore, the sense of rotation of link 4 would be opposite to the sense of rotation of link 3. So link 3 is rotating in the clockwise direction. Therefore, in this case, link 4 would rotate in the anti-clockwise direction with reference to this vector as well. So this rotates in the anti-clockwise direction. So by doing so, you can get the omega 4, and once you get the omega 4, you can find out rubbing velocity at B it becomes omega 3 plus omega 4, since both are rotating in the opposite direction, multiplied by the radius of the pin at point D. So if you do so, you get the rubbing velocity at point B. The next point which we need to estimate in this problem is, we need to estimate what is the rubbing velocity at point C. So at point C, rubbing velocity, we can get it. Rubbing velocity at point C is nothing but rubbing velocity at C equals to omega 4 into radius of C. Very simple. Now rubbing velocity at D requires omega of length 5. So we need to find out omega of length 5, and to find out omega of length 5, you can say once you move to D, at D we are trying to estimate things. So we need to find out what is the velocity of point D. Velocity of point D or velocity of 4, 5. So velocity of 4, 5, considering it at 4. So velocity of point 045, considering it at 4, it is omega 4 multiplied by 014 and 45. Now consider 4, 5 at length 5, because this is a common point on length 5 as well as on length 4. So you see this link number 5, it seems to rotating with respect to this point. This is rotating like this. So this is nothing but omega 5 multiplied by the distance between 4, 5 and 1, 5. Distance between 4, 5 and 1, 5. 4, 5 and 1, 5. So now you can equate these two. Omega 5, 4, 5, 1, 5 equals to omega 4, 1, 4 and 4, 5. So by doing so, you can estimate omega 5, and once you estimate omega 5, then you can get the direction of omega 5 as well. Now you can look at this direction of omega 5 would be, since 4, 5 is here and 1, 4 is here, right, and 1, 5 is here, means both are lying on the same side. So the direction of omega 5 would be decided here, and that is again same as the length 4. Length 4 is rotating counterclockwise, so 5 also rotate in the counterclockwise direction, because these 2 points 1, 4 and 1, 5 lying on the same side of 4, 5. So you get this value, and then you can estimate what is the rubbing velocity at pin D. So with this, your problem is solved with all respect, whatever be